Alright, hello everyone. So for this question, let's go ahead and estimate the angles for number 1, the HCO bond angle in the ether diethyl ether, and for part 2, the HC end bond angle in the secondary amine diethyl amine. Here we have 4 different answer choices labeled A through D, proposing different bond angles for parts 1 and 2, ranging from 120 degrees to 109.5 degrees. So let's go ahead and get started with part 1, which is diethyl ether. To understand the Lewis structure of an ether, recall that they have the general Lewis structure of ROR. And oxygen contains 2 lone pairs of electrons, as well as 2 covalent bonds, to fulfill its octet according to its bonding preferences. Now, recall that R is an abbreviation for the carbon chain on either side of the ether's oxygen. In this case, we just so happen to have the same exact group, which is an ethyl group on either side of oxygen. So in this case, I'm going to replace the R group on either side with the ethyl group here. Now, when drawing out the R groups, recall that the atom with the higher bond preference should be in the middle. Carbon prefers 4 bonds, whereas hydrogen prefers only 1 bond. So because of this, carbon goes in the center. So I have 2 carbons here in the center on one side of oxygen, and then we have hydrogen atoms connecting to the carbon atoms. So on the other side, I'm going to do the same thing and add the same R group. So now let's talk about the bond angle. Recall that the bond angle is determined by considering 3 atoms that create 2 bonds in between them, and the angle is determined by the atom in the center of the angle in question. In this case, of the HCO bond angle, the atom in the center is carbon. So the angle is determined by the hybridization on carbon. Recall that hybridization is determined by the number of quote-unquote groups that surround a given target atom. And groups fall into 2 distinct categories for our purposes here. We have electron pairs and other atoms connecting to the atom of interest. Both of these things classify as quote-unquote groups. So focusing our attention on carbon, we have 0 lone pairs of electrons, but we have 4 other atoms connecting to carbon. This ultimately makes 4 groups in total, which corresponds to sp3 hybridization. So because the point of reference in the HCO bond angle is carbon, and carbon is sp3 hybridized with 0 lone pairs, the bond angle is going to be approximately 109.5 degrees. So that concludes part 1, and now let's apply the same procedure here to part 2. Now part 2 is a secondary amine, which has a general Lewis structure of 1 nitrogen atom connecting to 2 R groups, and 1 hydrogen atom with 1 lone pair of electrons on nitrogen. This is because nitrogen prefers to have actually 3 bonds and only 1 lone pair of electrons to satisfy its octet. So using the same rules as before, we're going to substitute the R groups of the general Lewis structure with the R groups in the given amine which once again happen to be ethyl groups. So here I'm going to make some space for myself, and at the center of the R group should be carbon, since it has a higher bond preference than hydrogen. So I have carbon in the center, and hydrogens attached to carbon. And so I'm going to do the same thing here on the other side of nitrogen, since both R groups are the same. So this time for part 2, we're examining the HCN bond angle, which means that carbon is once again the center, or the reference point. So considering the Lewis structure of diethylamine, we have 0 lone pairs of electrons around carbon and 4 other atoms connecting directly to carbon. This makes 4 groups in total. And corresponds to sp3 hybridization on carbon. Because carbon is the point of reference for this bond angle, and carbon itself is sp3 hybridized with no lone pairs, the bond angle should once again be approximately 109.5 degrees. And there you have it. This means that our answer is option C in the multiple choice, where both parts 1 and 2 are approximately 109.5 degrees. So with that being said, thank you so very much for watching, and I hope you found this helpful.